Now that we've created our standard curves using the two functions, we are ready to quantify the protein concentration in our unknown samples. We had two different unknown samples, the student unknown and the instructor provided unknown. I'm going to show you how to do the calculations using just one set of those samples, and then you would just need to replicate the exact same procedure for the second unknown as well. I'm going to go ahead and copy the information, all the dilutions and absorbance for one of these samples over here by going to Control V and copy it. I will then go ahead and place it in my actual chart where I'm going to be doing my calculations. So I've already done that over here, but basically you will go to where you need to paste it, and again I transpose them so that instead of being horizontal they were now vertical. I also placed in the dilution factors for these unknown proteins. Now our unknown protein sample, we have no idea what the concentration is, so we did not know where the absorbance was going to fall for these proteins. We want to make sure that at least one of the dilution factors will lead to an absorbance within the linear range of the protein, or the reliable range, to be able to quantify the protein accurately. For the blank corrected absorbance here for the PSA curve that we've created, the range that we can actually use is right here. So if the absorbance of our unknown sample falls between 0.146 and 1.229, it can be reliably quantified. If it falls outside of that range, it is harder to quantify it accurately, because our standard curve was not designed for the numbers outside that range. So the first thing we need to do is obviously blank correct our new unknown samples absorbance as well. So we will do that here. So blank corrected absorbance. We are going to go ahead and right now I will just show you that you can go ahead and take the same blank that is here as your absorbance blank for the unknown sample. You can also, as I mentioned in class, use the average of all the blanks that you have. So you had a blank for your student unknown, a blank for your instructor unknown, and a blank for your BSA dilutions. You can take the values for all three of them, average them out, and use that combined blank for all the numbers that you are going to be looking at as well, which might be a better idea since you are going to be using that multiple times for multiple samples. So in this case, I'm just going to go ahead and use this one blank, and I got the value to 0 now because I essentially zeroed it by removing the blank absorption, which was the background, and then you can again drag it down to take the formula all the way, and now you have your new numbers. If you look at these new numbers, multiple ones fall within the range that we were talking about. The range was 0.146 to 1.229. Both 1 to 100 as well as 1 to 10 falls within the range. When there are two values that fall within the range, you want to see where they fall on the curve itself. 0.113 is pretty close to the edge, so it may not lead to as accurate a quantification as if it was something within the central portion of our graphs. So 0.608 is nicely placed within the center of our standard curve, and that's the one that I'm going to go ahead and use to then quantify our protein samples. Now in the first table that you're going to present in the paper, you do not actually need the actual quantification. All you need to do is present the information for each one of your dilutions along with the absorptions. So you're going to give me two columns essentially. So you will have the dilutions and the absorbance at 595, and make sure that it is the blank corrected absorbance that you're going to provide me in the actual paper. You're going to paste them in here as such. You want to paste them as values so it doesn't change. Now, because I'm only doing one particular sample, I'm going to go ahead and pretend that this is just one of the two, and I'm going to essentially take the exact same information and copy it again. So this was, let's say, our student unknown. So you can go ahead and merge and center this title, so we know that these values are from your student unknown. These are our column names. We can make them more apparent by going up here, and then you are going to copy this information in for the instructor values as well, and make sure to give the title for the instructor unknown. So this is one way that you could potentially present that graph. Another way that you could present the same graph would be to show the dilution factor for your samples in the first column, and then remove this, copy, and then show the student absorbance here, and then instructor absorbance in front of it, so that we have all the information that is needed, and we have all the numbers presented. Make sure that once you have done that, you are correctly presenting the information, and that it is correctly formatted. So in this case, you want to make sure all the columns are either presented centered, or all the numbers are presented left aligned, one or the other. In my case, I'm choosing to present it all as centered. And then you want to make sure to have your borders to show the edges of your table. And once you have copied and pasted the table itself into the Excel, into your Word document, you want to make sure to have the title and caption along the top of this graph or this table. So this is how you would be presenting that. Now you will then have another paragraph of text where you will talk about which one of these numbers fall within the range of your standard curve, and those are the numbers that you will then use to quantify the amount of protein present there. So as an example, I will show you for this particular number, 0.608. If the absorbance is 0.608 for your actual sample, this, you have to remember, is 1/10 diluted sample. So it's not your undiluted sample, but rather a diluted one. You are going to use first the linear equation, so linear trend line, linear equation to calculate your absorbance. For that, you're going to go ahead and substitute 0.608 for y, and then solve for x. So in this case, you can go ahead and do that by putting in the formula in here and saying the x is going to equal y minus 0.1001, and then divided by 0.7743 in the denominator. And here you have the actual concentration of protein in this diluted sample. However, this is not your final concentration because this was 10 times diluted. So you want to make sure that the value that you present to me in your actual table takes into account that dilution factor. So you want to multiply by 10 to give me the final concentration. And that would be your 6.55 mg per mil or milligrams per milliliter concentration. You will then repeat this same exact procedure using your quadratic function or the polynomial equation that you have here. You can take this equation and put it into this particular website that I've shown, and when you substitute the value of your x